Anytime we're talking about functions being transformed, we have our original function, which we simply call the function, and then we've got our second function, which is called the image function. On the original function, we'll have a point, and on the image function, we have an image point. So what we're going to look for in this example is the image point that corresponds to a certain point on the original function. And we don't actually need to know either the original function or the image function to be able to do this. We just need to know the transformation that's happened between them. So our image function is g of x, and it is made by f of minus x, which tells us that g of x is f of x reflected in the y-axis. So that tells us that any point in the on the original function gets reflected in the y-axis. So hopefully you'll recognize that our coordinates are going to be x, y for our point and negative x, y for our image. So now that we know that, the point -4, 2, so -4, 2 is going to be here. It is reflected in the y-axis, so its coordinates are going to be +4, 2. So our image point is 4, 2. Having a look at the second example here, the function m of x is transformed into p of x equals negative m of x. So p of x equals negative m of x tells us that p of x is m of x reflected in the x-axis. So if we have a look at a point here, it's reflected in the x-axis, which means that the x-coordinate will stay the same and the y-coordinate will be negative. So this is x, y. This is going to be x, negative y. So this time we're trying to find the point on m of x, which corresponds to the image point, 3, -2. So we're starting with the image point and we're reflecting it back to the corresponding function point. So we can sketch out a little graph, 3, -2, here it is here. So if that is our image point, then our corresponding point on our original function was going to be 3, 2. Therefore, the point is 3, 2. So really the only thing to remember with these types of questions is working out, is it reflected in the x or y axis, and then adjusting the coordinates accordingly. The other thing that we can do with these types of functions is describing the transformation. So if we're told that g of x is equal to negative f of x, the transformation is g of x is f of x reflected in the x-axis, and that's all you need to write. On this next one, we've got -2x, so we've got two things happening. So g of x is f of x reflected in the x-axis and vertically dilated, because the factor is outside the function, vertically dilated by a scale factor of 2. So you need both of those pieces of information. In this one, we've got a negative factor of 1 inside the bracket, so g of x is f of x reflected in the y-axis. And on the last one, we've got a factor of -5, so g of x is f of x reflected in the y-axis, because the factor is inside. The factor applies to every x in the function. It's reflected in the y-axis and it is horizontally dilated by a factor of 1/5. Remember, when the factor is inside the bracket and applies to each term, it's a reciprocal relationship. Notice that it is not enough to say it's horizontally dilated by a factor of -1/5. You need to specify that it is both reflected in the y-axis and horizontally dilated. You need to spell both of those out separately. That's enough to get you going on exercise 3F.3.